Angular momentum has several useful definitions which can be applied to different situations. One of them is the cross product of the radius of rotation and the momentum. And another one is the rotational inertia times the angular velocity. So these can be applied to find the angular momentum if you only know some of these other properties of a system or an object. So we can look at an AP exam problem which deals with this. So we have a particle of mass m moves counterclockwise around a horizontal circle of radius r as shown above. The angular speed of the particle is given as a function of time t by bt, where b is a positive constant and t is greater than or equal to 0. And our question number 32 on the AP exam is, what is the magnitude of the angular momentum of the particle about the center of the circle as a function of time? And here's a diagram from a previous question with the situation of what's going on in this case. So we just have this particle rotating in a circle, pretty simple. So we want to find the magnitude of the angular momentum. In this case, we do know the momentum and the radius of rotation, so we can use the cross product definition where angular momentum is equal to the cross product of radius times momentum. And in this case, this is the radius times the mass times the velocity, because this is equal to, this is the definition of momentum, it's mass times velocity. And we don't have the exact velocity, but we do know the angular velocity, and there's a definition which says that the velocity is equal to the radius of rotation times the angular velocity. And here we know that the angular velocity is given by bt, so we know that the velocity is equal to rbt. So this is what we know so far. And we can sub in this definition for velocity, say that angular momentum is equal to the cross product of the radius times m r b t. And because the angle between these two vectors that we're using is just 90 degrees, we don't have to find the real cross product. What we can just do is multiply the magnitude of the first vector by the magnitude of the second, and that will get us the exact same magnitude as we would get if we used an actual cross product, because they're just 90 degrees from each other. So our final answer, when we multiply this all together, is that the angular momentum is equal to m r squared bt, just like this. And this is option C on the AP exam, question 32.